How does a magnetic float switch work? Liquid level measurement and control is all around us in our everyday lives, from your car fuel tank to your toilet cistern. But liquid level measurement is also used extensively in production and processing plants, such as chemical plants, refineries and distilleries. Too much liquid and we risk spillage, waste, or damage. Too little and we run out of product, or pumps and systems run dry. Each case represents a cost and also often a danger. So, let's look at how a magnetic float switch works, to understand how the technology enables rugged and reliable operation. Day after day, the need for rugged and reliable point level measurement stems back more than a century, to control water levels in boilers and other appliances. Trusted reliability in aggressive environments. Established as the standard instrument for industrial level measurement in control, particularly in aggressive and extreme environments, magnetic float switches have proven to be a successful and reliable instrument in use throughout the world for a multitude of both routine and safety-critical applications. Components of a typical horizontal float switch. Split into three main parts. A typical horizontal float switch consists of a switch enclosure, a switch mechanism and a float, as you can see here. Let's understand the function of magnetic float switch by this animation. The simplicity and reliability of the magnetic float switch is down to its two opposing magnets, one wet side and one dry side. The switch enclosure literally houses the switch mechanism, encasing it within a tough alloy to protect it from damage. The mechanism contained within the housing provides the switching signal and contains one half of the opposing magnets. Finally, the float itself, well, it floats, rising and falling depending on the level of the liquid, but importantly, the bar on the float contains the other half of the opposing magnet. Simple snap action mechanism. When the liquid level rises in your typical storage tank, the float pivots upwards. The wet side magnet on the float repels the opposing magnet within the dry side switch mechanism in a strong snap movement, activating the switch. Similarly, when the liquid level drops in a tank, the float pivots downwards, repelling the opposing magnet and activating the switch. The beauty is that there is no contact between the switch mechanism and the float, no springs or physical interaction, just a snap action when the opposing magnets repel, and the only parts which come into contact with the liquid is the float. This is why magnetic float switches have proven to be ideal for long-term, low-maintenance use, since there are few parts to wear out, plus are also particularly suited for aggressive environments, since the snap action switch is unaffected by viscous liquids, temperature or pressure.
Thanks for watching, and if you liked this video, please subscribe our this channel and stay with us for more informative videos.